Hi, this is Mr. Max. This is my last series on vectors, 3D vectors, and I have prepared about 16 questions that you can go through um, and also use the application of the dot product or the scalar product. You can also use when you have an angle between two vectors, parallel vectors, and perpendicular vectors. Okay, let's go into the question one directly. You have got three vectors. Vector A given by 2, negative 2, 1. Vector B, 2, 6, 3. Vector C is given by P, and P plus 1. Components. First thing they want you to do is you are supposed to find the angle between the two vectors. Now, this should be very straightforward. I have the formula over here for you to find the angle between the two vectors. So we're going to find the dot product, and we're going to say A dot B to see what we get. Of course, um, you have 2 times P. Um, it's the dot product of vectors A and B rather, so it's 2 times 2. So that will be 2 by 2 plus negative 2 times the 6 over here plus 1 times 3. Maybe it's best if I write it in this way, then it's easier for now for you to perhaps follow what I'm doing over there. Of course, you grab your calculator, this will give you negative 5. Another thing worth knowing is, for example, we're going to find the magnitude of vector A, and I'm also going to do the magnitude of vector B. Vector A, obviously you just use Pythagoras' theorem. So vector A, the magnitude is 2 squared. You will also notice that as I square each component and a component has a negative, I'm not necessarily going to put a negative in here. Because what it is if you have a negative value squared, the answer will be exactly the same because anything that you square eventually gives you a positive answer. So I'm not going to put that negative there, but remember it is there, but it's the whole negative quantity that should be squared. So avoid putting a minus there without brackets. So continuing with the components of vector A, then you have 1 squared as well. I'm going to multiply that obviously by vector B, which is again 2 squared plus 6 squared plus 3 squared. So obviously the first one will give you 3 and the second one will give you 7. Okay, which basically is 21. Now we can actually calculate the angle between the two vectors. So you will say cos theta will be negative 5 over 21. So obviously you find the inverse cosine or arc cos, and you punch that in into your calculator. You get 103.774 and some odd degrees. Now we always have to give the angles in degrees to one decimal place, and so this is going to be 103.8 degrees correct to one decimal place. All right, so part B of the same question says the value of P. You're supposed to find the value of P for which B and C are perpendicular. So just so that you can be clear, if you are dealing with perpendicular vectors, then the dot product of those perpendicular vectors is equal to 0. Okay, but it's B and C rather, so let me just use B and C. So it must be vector B dotted with vector C should give me 0. And what do we know? We know that vector B um, is equal to, let's just go get the components of vector B. So it's 2, 6, 3. Vector B is 2, 6, 3. and vector C is the one that has the p's, so p and then p plus 1. And now when we obviously find the dot product, and we have to let it equal to 0, and that means we're going to say 2 times p plus 6 times p plus 3 times p plus 1. Well, that should give you 0. So that's 2p plus 6p plus 3p plus 3. Should be very careful here when you are doing this expansion over here. That 3 times 1 gives you -3, or +3 rather. So there are some like terms here. It's just 11. So you have 11p plus 3 is equal to 0. Of course, this becomes a very straightforward linear equation, and at AS levels, we expect you to know this answer. Okay, so that is the value of p. And very important, the question just says value, so it's just 1. Right, let's get to question 2. Question 2 has a little bit of a parallel vector in it somewhere. So I thought that maybe I can just add a few sentences or notes with regard to parallel vectors. Now, the thing about parallel vectors, if the parallel vectors, they go in the same direction, like what I'm indicating with vector A and vector B, and they might not necessarily have the same magnitudes. Now, what is important that you realize, the angle between them is obviously going to be 0. There is no angle formed here. Okay, because these vectors, they do not meet. So when we take the cosine of 0, you punch that in, you get 1. So in a nutshell, that you have the dot product of vector A and B is then equal to the magnitude of vector A times the magnitude of vector B. That's another way you can check for that. Of course, we're not mostly going to focus on this type of scenario, but it does exist. Another thing that you're worth noting is that if you have parallel vectors, then there is a scalar multiple between the two vectors. And you will see that more as we continue. Right, so first they give us vectors A, B in the form I, J, and K, and then they say point A is the point -3, 3, and 3. Find the coordinates of B. In order for you to find the coordinates of B, I'm going to write this in column vector form. So that's 2, -3, and 6. Of course, you are free to continue using the I, J, and K. And vector OA, position vector OA, because if the coordinate point is that, then the position vector is going to be exactly that. Right, so what is it now that we know? We know that from our position vectors that AB is OB minus OA. So it's the terminal point, the position point of the terminal minus the position point of the initial. So what do we then have from our information? We have that AB, I will write AB under AB, so it's 2, -3, and 6. And we do not have OB, but we know that we subtract OA, which is -3, 3, and as well as 3. Now, in order for us to find OB, because once I find OB, then I can find the coordinates. So I'll take this whole thing and I'll add it on that side. So that's 2, -3, 2, -3, and 6. And I'm going to add it with the other one here, which is -3, 3, as well as 3. And that's going to give me vector OB. So therefore, vector OB is going to be, when you add it, obviously you're going to have 3 plus negative 3, 2 plus negative 3 is negative 1. Negative 3 plus 3 is 0. 6 plus 3 is 9. So if this is the vector, the position vector of OB, then the coordinates of OB, then the coordinates of point B rather, would be nothing but negative 1, 0, 9. Okay? And that is what they were asking us to find here. Find the coordinates of point B. Right, let's go into part B of the same question. So they are saying the vector CD is minus y plus 6j plus qk, where q have different values. And they say if AB is parallel to CD, okay, find the value of q. Here's the thing about parallel vectors. So let me first write down what I know. I know from before that AB is 2, negative 3, as well as 6. Okay, you can just go back just to make sure that you have write it down correctly. AB, as you can see, is 2, negative 3, 6. Okay, as I'm given there. Now, another thing that I will also write down is that I know that CD, vector CD, is negative 4, 6, as well as Q. Now, if you are told that vector AB is parallel to vector CD, then it implies that vector AB should equal to some scalar quantity of vector CD. Okay, so in a nutshell, then I'm using this type of scenario over here that I've put in this rectangular box. So let's then just go ahead and write the stuff in. So vector AB is 2 minus 3, 6 should equal to some scalar quantity of CD, which is negative 4, 6, as well as Q. Right, so once you're like this, you can obviously go ahead and equate the two by multiplying each component there. Now this gives us 2 is equal to negative 4 times k. If you multiply 2, let 2 equal to that scalar quantity multiplied by that. By the way, you're going to get the same answer when you did negative 3 is equal to 6k. This is going to give us that k is negative 1/2 either way. Now if I have that, now I can actually find the value of q. So for me here now, I'm just going to say, okay, 6 is equal to qk. Now since k is negative 1/2, so that will be 6 is equal to q times negative 1/2. Now of course, to get rid of that negative 1/2, you just multiply both sides by the inverse. So you will multiply here by negative 2, and you also multiply here by negative 2. So that implies that q would be negative 12. And surely that is the answer we're looking for over there. Okay. Now there's a second part to this question. Obviously it now says, well, you were supposed to find the value of q if vectors A, B, and CD are perpendicular. Now, the thing about perpendicular vectors are easy to determine. Okay, so what you're going to do is you're going to take the dot product of that. So I have the formula over here, so that you know that if vectors are perpendicular, then the angle is 90 degrees. And the thing is, when you plug in cosine of 90, you're going to get 0. So therefore, if you have the dot product of A, or the magnitude of vector A times the magnitude of vector B, that should give you 0. Okay, if you cross multiply, just have that, just correct it a little bit. So if you were to say, supposedly you multiply both sides by the magnitude of vector A times the magnitude of vector B, and you do the same here, you multiply this by magnitude of vector A times the magnitude of vector B. Well, what you're going to be left with will just be vector A dotted to vector B should equal to 0. So in this particular instance, in order for us to prove that these two, or to find the value of Q, we should have that AB, vector AB dotted with vector CD should give us 0. So we just have to prove that, or to find that, and then we can actually find the value of Q. So what do we know? We know that AB is 2, -3, and 6. We know that CD is -4, 6, as well as Q. That's what we know. Okay? So if you were to go ahead and multiply out these two, or find the dot product rather, you're going to have 2 times -4 plus -3 times 6 plus 6 times Q. And this should equal to 0. Now let's just go ahead and clean this up. So I have nothing here but -8 minus 18 plus 6Q. That's equal to 0. So that's -26 plus 6Q is equal to 0. So it becomes a linear equation that you can actually start solving. So it becomes 6Q is equal to 26. Then Q is 26 divided by 6, which is the same as 13 divided by 3, which you can go ahead obviously and leave your answer and say Q is equal to 3 goes there. Well, 3 goes there 4 times and 1/3 remains. Okay, so for this particular question, that is what our Q value is. Okay, let's go to question 3. Question 3 is very important. So they are asking you here, they're saying OABC is a triangular pyramid. The position vectors of A, B, and C relative to the origin are given below. So first we have to find the magnitude of vector A. So that is quite straightforward. You take 2 squared plus 4 squared minus 4 squared. I'm going to put it in brackets over there. And then you take the magnitude of vector B. So that is obviously 0 squared is just going to be 0. So I'm not going to work with that. -4 squared plus 3 squared. Okay. So vector A, so this is going to be the square root of 36, which is 6. This is 16 plus 9, which is the square root of 25, which gives you 5. Okay, whatever it could be, units, you can just write it in if you want to. Calculate angle AOB. Now, in order for you to calculate the angle that's between that, so if you were to think of this question, if I was to show you maybe in a form of a diagram, just suppose this is our origin, okay? So let's say this is our origin, and we take 3 points, one over here, so this could be my point A, B over there, and C over there. And if you were now to join that with that with that, so when I represent that as a vector, O to A, obviously that is going to, if I have to go back to O to A, it's 2, 4, -4. So this is going to be 2, 4, -4. That's O to A. O to B, let's go back and check it. So 0, -4, 3. So this here is 0, -4, 3. and O to C, represented by vector C there relative to the origin, is 0, 1, 1. So this is 0, 0, 1, 1. Okay, so what they're asking is angle AOB. So it's this little angle over here. And in order for you to find that angle, you have to now take these two vectors, OA and vector AB. Now, we already know what the magnitudes of those vectors are. So the only thing that we are left to do is we know that the magnitude of vector OA is equal to, we work it out from before, magnitude of OA, 6 units. We also know that the magnitude of OB, okay, was 5. OB, we've calculated it. So we just have to find the dot product of this. So OA, dot over OB, of course. We can go ahead. So it will be 2 times 0 plus 4 times -4 plus 3 times -4. Well, you get -28 as an answer. Right, so now I can actually calculate that angle. So in order for me to find that angle, because they say calculate the angle, so I'm just going to add a page there. Let's just add a page, insert a page. Page. Let's see. It gets to the right place. Okay. Now, for us to find the angle, so you know that the angle is cos theta is vector OA dotted with vector OB, and this should be divided by the magnitude of vector OA times the magnitude of vector OB. So in this particular case, I have -28 should be over multiplied with, was it 6 times 5 from our answer before? So that is like -28 over 30. Okay, so cos theta is going to be -14 over 15. So I just simplified that, that's all. So in order for me to find that angle, of course, you just take the inverse cosine or cos octa of that, of course. And you just make sure you grab your calculator and then you punch that stuff on your calculator. So I get 158.9605302 degrees. So I just want to go back to the question because I think they say you must give it to the, very important, to the nearest degree. So I'm just going to make sure that you highlight that. Very important that you always read your questions. So let's give this answer then to the nearest degree. And this answer then becomes 159 to the nearest degree. Okay, so there's another part. Show that angle AOC is equal to 90 degrees. So let me just write down what I have. I know that OC, and please go back, was represented by 0, 1, 1. I also know that OA, vector OA, has 2, 4, as well as -4. See, just go back and make sure that we have everything. 2, 4, -4. 2, 4, -4, 0, 1, 1. Good. Now we can actually prove something. In order for us to do that, the only thing that we need to do, we don't have to calculate the angle. They do not ask us to calculate the angle. The only thing that we need to do is we need to prove that if we take the dot product of OC, or vector OC, and vector OA, that we are going to get 0. Of course, that will be 0 times 2 plus 1 times 4 plus 1 times negative 4. Surely this gives you 0 here, plus 4, minus 4, and then you get equal to 0. So therefore, AOC is equal to 90 degrees. Okay, that's all that you had to do, and that's the guard. Right, when they are asking you and giving you these questions here, they say find a vector parallel to B, vector B plus vector C, with magnitude of 10. So the key word obviously here is parallel. And then you're also going to hear other words as you go along, that you will hear things like in the same direction. So there is the concept of a unit vector that you need to apply. So the one thing that you need to do is find the magnitude of the vector. So we're going to find the magnitude of vector B plus vector C. But before we do that, perhaps we'll just have to find vector B plus C, what that gives us. Now, from our work before, we know that vector B is 0, negative 4, as well as 3. And we know that vector C was nothing but 0, 1, 1. So go ahead, back and check. So on top you have a 0, then you have a negative 3 over here, and 3 plus 1, then you get 4. Okay, so now we're going to find the magnitude of this. So that is the very first step. So we're going to find the magnitude of that. So obviously 0 squared is just going to be 0 squared, so I'm not going to add that. So that's 9 plus 16, which is 25. So square root of 25 gives me 5. Now, here's the thing about the second one. We have to divide the given vector by its own magnitude, by its own length. So the way you do that, the given vector obviously is given to us. Maybe I'll write it like this, because they were saying that before I get to that part, they were saying that find a vector, and this vector has a magnitude of 10 units. Our vector here has a magnitude of 5 units. So what you then realize, okay, you say, wait a minute, 10 divided by 5 give you 2. So what that means is parallel vectors, we're looking for a parallel vector that is twice as long. So we're looking for a parallel vector that is twice as long. So in a nutshell, I'm going to say, okay, it's basically 2, that scalar that I was talking for, 0, negative 3, 4. So our answer would therefore be 0 over here, negative 6 over there, and 8. That is if you multiply each component by that scalar quantity. Of course, there's also another way that you can do this question, and I'm going to write it here. So the second way that you can do this is a bit longer, but it will come in handy whenever you're going to calculate and find that. So the first thing is a unit vector. Very important that you know that. I wrote it somewhere. A unit vector is in the direction, let's say the unit vector in direction of B plus C would be, when we calculated the magnitude, is 1 over 5 times the vector. So what was the vector? It was 0, negative 3, 4. So when you have 0, negative 3, 4, so I hope you know how I got to the unit vector here. Okay. So you have to create a unit vector is a vector simply with a magnitude of 1, size of 1. The vector, you will take 1 over the magnitude of that particular vector. So let's say vector V, and then you simply divide that into that particular vector. So you multiply that. Okay, you can say multiply by a vector, whatever the vector would be. Okay, so x, y, z. Okay, something like that. All right. So any case, so I'll take 1 over 5, and if you make every component here, obviously multiplying every component here by 1 over 5, that is 1 over 5 times 0 will just be 0. 1 over 5 times negative 3 is negative 3 over 5. 1 over 5 times 4 will be 4 over 5. So what I have here is a unit vector. And you can go ahead and check that this will give you a unit vector if you were to take those components and find the magnitude of them. So if you were to take the magnitude of each one of them, so whatever this vector is here, if you were to take the magnitude, you're going to get the magnitude of 1, okay, under the square root. So this is what it is now. So I have now effectively a unit vector. So if they are saying we have to find a parallel vector, so a parallel vector which happens to be 10, the magnitude of this vector is 10, so I'm going to multiply 10 with my unit vector. And if I do that, I'm going to arrive at the same answer like before. And surely you can see 10 times that is 0, 10 times negative 3 over 5, so just grab a calculator, 10 times, of course, negative 3 over 5. Well, you're going to see you get a net negative 6 here. And then obviously going back to my calculator, 10 times, well, of course, this now becomes 4 over 5. Okay, and that's 8. And surely this is the same answer like what I had before. Okay, which is over here. So there's one way of doing it, where you could just say, okay, I'm given the other one's magnitude is 10 and my magnitude is 5, so the other one has to be twice as long. Or you find the unit vector, so you take to find the unit vector, obviously you need to know what is the magnitude, 1 over that magnitude times the vector, and that gives you the unit vector now. And then you multiply that unit vector by that value that you are given in your question. I have a follow-up question that I want to see if you can use it. So let's suppose the unit vector, still on the concept of the unit vector, which is nothing but just a vector with a magnitude of 1. So we'll say that v is equal to, or let's say the unit vector, we're going to represent it by using u, is going to be whatever that vector is, okay, divide that by its magnitude. And to an extent it makes sense. That's how you get a unit vector. You just divide the vector by its magnitude. Okay, so in this particular case you have got vector v, which is given to us as 2I minus 3j plus k. So of course, if I have to calculate the magnitude of this, it's going to be 2 squared, okay, plus negative 3 squared plus 1 squared, 1 obviously being here, and then taking the square root of that, so that's 4 plus 9 plus 1, so that is going to give me the square root of 14. So now that I have found the magnitude, so I'm going to divide, I'm going to say, okay, the unit vector is going to be 1 over root 14 times our particular vector. So in this case, it's going to be nothing but each component of that. So it will be 1 over root 14 in brackets 2i minus 3j plus k. You can stop there if you want to, or you can just distribute that 1 over if you want to as well. And if I distribute over, I'm going to get 2 root 14 for I minus 3 root 14 in the j direction plus obviously 1 over root 14 in the k direction. So if you were to take the magnitude of this 2 root 14 or minus 3 root 14 plus 1 over root 14, if you were to take the magnitude of that, now you're going to get the magnitude of 1. You have to do that. Okay, so that was just a spicy question that I have added in there. So let's go to question 4. What are we told this question? We are told that relative to the origin, the point A has the position. I'm going to write them as you know, it's totally up to you if you want to keep it in that form. I'm going to write it as column vectors, so that's 4, 7, as well as a p, especially when I have this, other letters that I need to find. And then I also do the same for OB, because OB was point B, so it's OB is going to be 8, -1, as well as P. Okay. Now, when they say we must find the dot product of these, so nothing to be afraid of. So you say 4 times 8 plus 7 times -1, okay, plus P times P. Okay, so if you were to do that, finding that, obviously that gives you 32 minus 7. 32 minus 7, make sure get 25. So it gives us 25 plus p squared. So that is what the first part wants us to find. Part B says, hence show that there are no real values of P for which OA and AB are perpendicular. So what we know is if the two vectors are perpendicular, then their dot product should give you 0. Now what we have from our answer before, we have 25 plus p squared is equal to 0. This makes this p squared equals to -25, and this is now not possible because you can't take the square root of -25. So there are no real values for p. Okay, so you can now go ahead and conclude that vector OA is not perpendicular to vector OB. Okay, for any real value or values of P. All right, so please excuse my handwriting, but you get the idea. Right, now they say find the values of P for which angle AOB is equal to, so let me just have, so this is O, and let's say that is A, and let's say that is our B there. Okay, so what we know is we have got OA, we have got OB. Okay, right, I'm just going to close this down. So what is OA? Now OA was nothing but 4, 7, we can go back to find OA. OA was 4, 7 minus P. What else? OB, well, OB is 8 minus 1. We have to go back all the way. OB is 8 minus 1 and P. I'm just going to write it down. 8 minus 1 and P. Right, so they are saying find the values of P for which the angle AOB. So this angle here is 60 degrees. Now we know from our formula that cos theta is equal to, very important that OA dotted with OB all over the magnitude, the product of the magnitude of these vectors. But since cos 60 degrees is equal to a half, just make sure that you know the special angles, otherwise just use your calculator to get us a half. That now implies that I can actually continue and say, wait a minute, a half is equal to, now we did not calculate as of yet vector OA and vector OB. And maybe I should do that. So let's find the vector OA dotted vector OB. I'll come back to this half. We just change the color a bit. So what do we know? We have the magnitude of vector OA, which is given to us. I have it over here, 4, 7 minus P. So that's going to be 4 squared plus 7 squared plus negative P squared. So if you were doing this is 16 plus 49. So that's a 65 plus P squared. I'm just going to leave it like that. Remember, minus P all squared is positive. Let's also find the magnitude of OB. The magnitude of OB, well, that is 8 squared plus negative 1 squared plus P squared. No need to put it in brackets. This is 64 plus 1. Well, this will also give you 65 plus P squared. The two are equal. Okay, so creating effectively an isosceles triangle, or an equilateral triangle, by the way, if that is the case, because these angles too will then be 60, 60 each, because these two distances are the same. Base angles are equal. Anyway, that's interesting to note. What else do we need? Of course, we also need the dot product of these two, because we will have to use it, but we did calculate the dot product, if I'm not mistaken. The dot product is P 25 plus P squared, so we know that the dot product, so another thing we know that the dot product of OA and OB from our work before was 25 plus P squared. So let's just go ahead and complete our formula now. So if we have cos theta equals to, and we know that cos theta is nothing but 60 degrees, so we can just go ahead and put 60 here. And that is equal to 25 plus P squared over, now what was our two magnitudes there? Our two magnitudes was nothing but these two times themselves, so we're going to have 65 plus P squared. Now here's the thing, if I multiply these two together, the square root disappear, okay? So if you multiply this times that, is the same as saying square root of 8 times square root of, I don't use 8, but let's use a number like a, square root of a times square root of a, which is nothing but, which is just going to be a. Using that fact, that if you were to multiply, this with this, okay, if you multiply those two, it will just give you 65 plus P, like what I have over here. Now, this all good gives me 1/2 is equal to 25 plus P squared over 65 plus P squared. Well, because of a habit, we'll be using maybe cross multiplication. Okay, so let's just add another page. So let's see where we are. We're here. So I'm gonna add a page, insert page. No, we are going to append it. Okay, page, append page. All right, let's see. It should be where I want it to be. So now if you cross multiply, you're gonna get 2 open bracket, that is 25 plus P squared is equal to 65 plus P squared. You know, this is becoming very straightforward for anybody to do. This over here is 50 plus 2P squared equals to 65 plus P squared. Okay, the 50 comes from 2 times 25, distributing that 2. Then I have 2p squared minus p squared equals to 65, take away 50. Okay, that leaves me with p squared equals to 15. Then p will then equal to the square root of 15. So p has got two answers, positive and negative, the square root of 15. Okay, so it's totally up to you now if you want to leave your answer to 3 significant figures. I'm just going to leave my answer like that. Because here's also another hint. It says you must find the values of p. Okay, so it implies p has got more than one answer. Alright, so if you don't want to write your answer like this, you can say p equals to the square root of 15 or p equals to the negative root 15. Good. Question 5. So you have got vectors here, u and v, and they are saying that the p that you see there is a constant. Find the values of p for which the two vectors are perpendicular. So again, perpendicular vectors means that the dot product should equal to 0. But of course, we can actually go ahead and say u dotted with v should give you 0. So if you do that, you get 2 p squared, if you multiply that by that, plus minus 2 times p minus 1 plus 6 times 2p plus 1. That should give you 0. So let's see, we have 2p squared. Here you must be minus 2p, so plus minus 2p plus 2 plus you have got 6 times 2p, that's 20, that's 12p inside. 12p plus 6 give you 0, of course. Can get rid of all these brackets. So I'm going to have 2p squared minus 2p plus 2 plus 12p plus 6 is equal to naught. Let's just clean it up. 2p squared is going to be 2p squared. You have 12p minus p, that's going to give you 10p. 2 plus 6, that's giving you 8. Of course, you can divide throughout by 2 over here, 2 over here, 2 over here. That's just to simplify it. And if you simplify it, its quadratic becomes p squared plus 5p plus 4 equals to 0. Now 4 is 1 times 4, so the numbers you have got p plus 1, p plus 4 is equal to 0. So if you have to find the values of p here, and of course you let each bracket equal to 0, p equals to negative 1, or p equals to negative 4. So they are saying in this case, they are saying find the values, keyword again, find the values of p. Right, so we did that. Now, they are saying for the case when p equals to 1, so if that is the case, maybe I should just write down what my v was. Originally, my v was p squared minus 2 as well as 6. So if you substitute 1 in there, so that's 1 squared minus 2, 6. So it's going to be 1 minus 2, 6. Alright, so that's what that one becomes now. See, that was, is it u? That was u. Okay, not v. Let's see u. Okay, now if what is v then? Of course, v was initially, if you have to go back to v, it was 2, and then you had p minus 1, and then you had 2p plus 1. So if p is equal to 1, so we're going to substitute So that's going to be 2, still remains 2. So 1 minus 1 is 0, and then you have 2 times 1 plus 1. Of course, that's 2, 0, done 3. Okay. So now what are they saying? Find the angle between the two. Right, so we can actually find the angle between the two. So the angle between the two, let's find the dot product. So u dot of v is going to give me 1 times 2 plus negative 2 times 0 plus 6 times 3. Of course, that's 2 plus 18, so this gives me 20. Okay. What's the other thing that I need to know? I need to know the magnitudes. So let's take the magnitude of u and multiply by the magnitude of v. So magnitude of u will be 1 squared, so over here, plus 2 squared plus 6 squared. So it's 1 squared plus 2 squared plus 6 squared. Of course, you can put that 2 squared in the negative in the brackets if you want to. And this is going to multiply with v, which is 2 squared plus 3 squared. Of course, if you were to clean this up, that's 36 plus 4, that's 40. So it's root 41. And this is 4 plus 9, no? That's 13. Okay, so now I have all my components. I can just go ahead and find the angle. So my formula is cos theta is equal to 20 over root 41 times root 13. Okay. Well, of course, this cleans up to 20 over root 533. The way you get 533, multiply these two, 41 times 13, you get the same answer. Doesn't have to do that if you want to. Of course, then obviously the angle will be the inverse cosine of this 20 over root 533. Okay, and then you go ahead and you punch that on a calculator. So we take the inverse cosine of 20 upon root, I'm gonna say 41 just so you can see, times root, I'm gonna have to put the times there, but anyway, root 13. Okay, well, you can go close the bracket, you get the answer. So it's 29.9 odd degrees, so it's 29.96895 and so on degrees. So that will be 30.0 degrees to 1 decimal place. Okay, they haven't specified, but I'm leaving it to 1 decimal place. Right, question 6. Again, I'll divide it into 2 videos because it's quite a lot of work, 16 questions. I'll see if I can go to question number 9 or 10. The position vectors of A and B are given to you relative to the origin, so you have to calculate the angle between them. Again, by now you should know the drill. Okay, OA, the magnitude of OA. We're gonna find the dot product for OA, dot of OB. Okay, so that's negative 3 times negative 1 plus 6 times 2 plus 3 times 4. Okay, so that's 12. It's 12 is 24 plus 3. That'll give you 27. And then if you have to find the magnitude of OA times the magnitude of OB, okay, magnitude of OA, well, that's going to be negative 3 squared plus 6 squared plus 3 squared multiplied by negative OB, which is negative 1 squared, 2 squared, 4 squared. So let's see, what do we get? You can use a calculator, of course. I've also shown you how to find the magnitude using a calculator, the special type of calculator. Anyway, if you were to do the one on top, so let's say you have root, I'm going to say 3 squared plus 6 squared plus 3 squared. Okay, no need to put that negative there. Okay, so that gives me 3 root 6 and multiply that by, of course, this is going to be 1. That's 4, so that's 5 plus 16. Okay, it looks like it's 21. Okay, so that's root 21. Now I have it, so I can calculate the angle. So the angle between the two is nothing but cos theta equals to 27 over 3 root 6 times root 21. Okay, now let's see what my angle is. So my angle is going to be 3 root 6 times root 21. Just going to punch it in the way it is. Inverse cosine, of course, make sure your calculator is in degree mode. So that's 27 over 3 root 6. Let's get out of there, times root 21. Okay, we need to close that bracket. So it gives me 36.699, so on and so on. So it's 36.699. Let's write them down, 2252. 2252, some odd degrees. Of course, it is then 36.7 degrees. This is to 1 decimal place. All right, so the next one, the point C is such that AC is equal to 3AB. So AC, let's work with AB first. So AB is nothing but OB minus OA. Okay, and let's see, what is OB from our previous work? So let's go back all the way, find OB, OB being negative 1, 2, 4. So that's negative 1, 2, 4. So it's negative 1, 2, 4. And what is OA? Let's go back to OA because it's relative to the origin. So you can just say it's OA. OA is negative 363. That's negative 363. So this is negative 363. And of course, if you were to do that, negative, this is going to be plus here. 3 minus 1 is 2. 2 minus 6 is negative 4. 4 minus 3 is 1. So this gives me AB. Okay. 2, negative 4, and so on. So what did they say? They say that AC is 3 times of AB. So it's 3 times of this one here. Okay. 3 times of AB. So that gives me multiplying each one of those components by this scalar. It's going to be 6, 3, and negative 12, and always 3. And now that I have that, remember the question wants you to find the unit vector in the direction of OC. Okay. Now, I'm not done because we still have to find that OC. So what do we know? We know that AC is OC minus or vector OA. AC is nothing but 6, negative 12, as well as 3. Vector OC is what we're looking for. Vector OA we know. Vector OA is 2, negative 4, 1. So just go ahead and write it in there. So that is 2, negative 4, 1. So in order for us to find OC, or vector OC rather, vector OC, of course this whole thing should add with that one. So 6, negative 12, and 3 should, rather very ugly way, okay. We should add. So let's go ahead and add. Okay, that's 2, negative 4, 1. Okay, because this whole thing must be added when it goes that side. So that gives me 8, negative 12, that's negative 16, and 3 plus 1, that gives me 4. Okay. So this is vector OC. Please make sure that I have it correctly. Let me just make sure. 6 OA. My OA. I wrote my OA wrongly. So just quickly go back to OA. Oh my goodness, OA is here. So my OA, I've written it wrongly. OA is negative 363. I was now wondering, why am I getting this whole thing OA is going to affect this answer. Okay, let's just go back and put OA. OA is negative 363. Always check your answers. So that's negative 363. And that's negative 363. Okay, 6, take away that. That is going to be 3. Now it makes a little bit more sense. And negative 12 plus 6 is negative 6. And 3 plus 3, obviously, that gives you 6. Okay, now that I have that, now I can actually answer the question, because just insert a page. Remember from my previous work, what I was talking about, the steps that you can make this a unit vector. The first thing, when you get questions like this, find the unit vector in the direction of OC. So now we know OC, now we find the magnitude of OC. So we say, find the magnitude of OC. You can also find that answer from there, okay? But the magnitude of OC, that is obviously going to be 3 squared plus negative 6 squared plus 6 squared, okay? Of course, all of this under the square root. Of course, this is going to give you 81, square root of 81, which is 9. Now, the unit vector, which is a vector of magnitude of 1, in the direction of OC will be 1 over 9 times vector OC, which happens to be 3, negative 6, as well as 6. Okay, well, you can go ahead and multiply each one of those things. You can say that is 3 divided by 9. Okay, so multiply 1 over 9, and then you have negative 6 divided by 9, and then you have 6 divided by 9. Of course, this cleans up nicely to a third, negative 2/3, and 2/3. You can leave it like that. Okay, so there's one way of solving it. Of course, there's also another way, but that's what you get, right? Good. Let's get to our next question. Question 7. Relative to the origin, the position vectors of A and B are given. And they are saying find the value of P for which angle AOB is equal to 90 degrees. Again, you know that for that business to exist, to be 90 degrees, you have to say OA dotted with OB should give you 0. Okay? So let's see, 5 times 2, that's 5 times 2, plus 1 here, times 7, plus 2 here, times P, 2P. Would give you naught. So we can actually find the value of P. The reason why it's equal to naught, because you're told that the angle of AOB is 90 degrees, and if the angle is 90 degrees, then this is perpendicular. Okay, so you can just clean it up. So this gives you 10 plus 7 plus 2P is equal to naught. 2P is equal to negative 17. Okay, so that implied that P is equal to negative 8.5. And that is my answer. Okay, right, let's go to part B. In the case where P now is equal to 4, so let me find a magnitude, or find a vector which has a magnitude of 28 as in the same direction. Good, so first let's write down what was vector OA again. Vector OA was 5 in the I direction, plus 1 in the J direction, plus 2k. I'm not going to underline those things, so I'm going to leave it like this for now. Vector OB, what I know, is 2 in the I direction, plus 7 in the J direction, plus 4k. Of course, all of this I'm just rewriting it from the question, okay, they were given to us over here. Does that make sense to you? Okay, now, the reason why this one becomes a 4, okay, because it used to have a P there, okay, so you can remember, you can see it, okay, it used to have a P over here, like so. So why am I writing a 4? Because they are saying to me that P is equal to 4 now, when P is equal to 4. So that's what I did over there. Okay. Now I have written down what I know. Again, before we do anything, we need to find AB. So AB is calculated by saying OB minus OA. Okay, position vector. Okay, so OB is 2i plus 7 in the J direction plus 4k minus, that is 5i plus j plus 2k. Now expecting an AS level student to be able to do the subtraction here. Okay, you should get negative I, and then you have 7 minus 1, so plus 6j, 4 minus 2 plus 2k. You got it? First one is minus 3. It's 2 minus 5. Minus 3j, minus 3i, plus 6j, plus 2k. All right, now that we know that, remember what is the next step? That was the first step. Okay, so we have AB. Now you must find the magnitude of AB. So magnitude of AB, you take negative 3 squared, 6 squared, 2 squared. Of course, everything here squared. It's 9 plus 36 plus 4. 36 plus 4 is 40. Square root of 49, well, that gives you 7. Right, now, in order for you to do that, I'm going to go back to the question. It says, find a vector which has a magnitude of 28. So that vector is a magnitude of 28, and it's in the same direction as AB. So, let's see how long that will be. So if I have 28 divided by this one, so this one is 7 times, no? 28 divided by 7. My goodness. Other way around. 28 divided by 7. So that one is 4 times as long. So my answer is simple. Whatever this vector will be 4 times whatever vector AB is. Okay? And that gives me 4, and what was AB? Vector AB was minus 3i. Just taking the components there. Plus 6j plus 2k. Okay, you can go back and have a look at that. Minus 3i plus 6j plus 2k. Of course, you can just distribute over. Okay, since I am over here, I'm just going to write it here, the space. Okay, very important. So it's going to be minus 12i plus 24j plus 8k. Now, of course, you could also have answered it in a different way. You could have made a unit vector and then you get to the same answer. Perhaps I can go ahead and show you. So it's long, but I can do that. Let's cancel that. Let's say insert page as append page. Okay, use that type of page. Right. So if you didn't want to do that, you could have said, okay, the unit vector in the direction, in the same direction, of vector AB would be that magnitude of that vector 1 over 7. We have already calculated the magnitude of the vector, so 1 over 7 times, so that's going to be 3I vector AB plus 6J plus 2K. So what I'm doing now is I'm going to find the unit vector. So this is giving me 3 over 7I plus 6 over 7J plus 2 over 7K. All right, so this is the unit vector. Okay, so let me just say that. That's a unit vector. Now, if you were to take the magnitude of this, take each component squared and so on, you're going to get 1. So what is it that we know? We know that we have a vector of magnitude 28. So that means 28 times 3 over 7I plus 6 over 7J plus 2 over 7K. So we can find that vector now. Because the question is saying, it's asking for this one that I have over here. The question is saying, find the vector, which has a magnitude 10 to 8. Okay. So if you grab your calculator, then you say, okay, 28 multiplied by 3 over 7, you're going to get 12. Okay. So this is going to give you 12I. And if you take the same, 28, and you multiply it by 6 over 7, okay, it's 4 times 6, which is 24. You get 24J, and if you take that same 28, you multiply it by 2, okay, that's 4 times 2, which is 8. That gives you 8K. And you will see that this answer over here, okay, pause it and check the answer, is exactly the same as my answer over here, okay. Exactly the same thing. All right, so whatever method works for you, maybe just remember, when you're given the question, you have to find AB, and you find AB using, obviously, your position vector concept. Right? The position vector of the second minus the position vector of the first. Okay, and once you have that, then you find the magnitude of that, and then you can work your way from there. Remember all the steps that I've showed you. Right, I think we can do one more question. Question 8. Relative to the origin, because we will continue tomorrow with the rest. I'll give you 16 questions and I'll finish them. And then at least you have enough to work with. Right, they're telling you all of that. So what's going to happen here, whenever you have unknowns like this, you know that somewhere, somehow, you're going to deal with simultaneous equations. Okay? What do we know? We know that OD, which is 1, 4K, is equal to M, and OA, which is 4, 1, negative 2, plus N, which is then given by OB, which is 3, 2, negative 4. Okay, so we're going to create the equations from here. We're going to create 3 equations. One equation, I'm going to call it equation 1. Is going to be 1 equals to 4m plus 3n. Okay, it's equating those components. Then equation 2. It's going to be 4 equals to m, 1m, plus 2n. And then perhaps we can create equation 3. Take note that here I can already use this 2 to find the value of m. Then I'm just going to write down the equations. So equation 3 is k equals to minus 2m minus 4n. So I'm going to solve this two first. Solve for m and n. And once I have those values of m and n, I'm going to substitute in equation 3 to find the value of k. Right. Looking at equation 2, I'm going to rewrite and make m the subject of the formula, which means 4 minus 2m. So moving that. Then I'm going to substitute into equation 1 everywhere we have an m. So that means it's going to be 1 equals to 4 plus 3n. Now I'm going to substitute 4 minus 2n over here. This is going to allow me to find the value of n. So this is 1 equals to 16 minus 8n plus 3n. So we move around. This is going to be 1 minus 16 equals to minus 5n. All this is 5n equals to 15 and n equals to 3. Okay. Now I'm going to come back here because of space. I'm going to come back here. So I will say m equals to 4 minus 2, because now I know what the value of n is. N is 3. Alright. So from here, m is equal to 4 minus 6 is minus 2. So now I know what my m is. So I'm going to bring in my equation 3, which is k equals to, equation 3 is k equals to, let's go back, minus 2m minus 4n, minus 2m minus 4n. Make sure we wrote it correctly. And we know that m is equal to negative 2 and n equals to 3. But m equals to negative 2 and n equals to 3. Substitute into equation 3. Substitute into equation 3. This is going to give me m, not rather m, but k minus 2 minus 4. Just go ahead and substitute those values. M is minus 2 and n is 3. If you were to go and work these out, you get that k equals to 4 minus 12, which is minus 8. So I have my 3 solutions now, and I can just go ahead and write them. So I'm going to say, therefore, m equals to negative 2. Just write it nicely. N equals to 3. And k equals to negative 8. These solution to the question it's looking for. Okay, there we go. Very interesting problem. Creating. It looks complicated at first, but you'll later see it is not that complicated. All right, question number 9. Looking at the time, that will be part of my second video tomorrow. If you need the notes, I can just definitely send it to you. So tomorrow I'm going to continue question number 9. Number 10, probably some sketches. You probably will see that as well in your textbook. And question 11, you also see this one in your textbook under advanced level. And um, question 12, well, something more diagrams. I've also added, we'll see the solution and we'll see how I work to get to those values. And question 13 all the way up to question 14, I have also worked out and give you the solutions. Question 14, question 15, I'm going to explain. And the last one that I'm going to explain will be question 16. So I'll do those questions tomorrow, and then we are officially done with our topic on vectors. Right. So that means we're going to have a look into differentiation. And once we look into differentiation, obviously, we're going to look at this type of questions. And I'm going to give you all the word problems on differentiation. Again, what I'm going to do is I'm going to work out about 20 questions that I'm taking and dividing it into the parts of particle mechanics and integration. That's what I'm going to happen this week. I'm going to finish all of that this week, and then I'm going to go ahead and I'll start with further trigonometry, further differentiation, further integration next week. So when you look at the calendar, so this week we're going to finish questions on differentiation and integration. Next week we're going to do further trigonometry and further differentiation. The week after that we're going to do further integration, and the last one, solutions to equations. All right, and most probably if I do find time somewhere there, I can work out last year's paper 2 with you. I'll only do one batch, and then maybe another paper 2 of them, and we should be fine for you to be prepared, especially with theme 2.